Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's podcast is brought to you by our Patreon and our patrons. And as a reminder, Sabrina's art will be coming out soon for every patron that has joined when we reach the 160 patron mark. And right now we're up to 146 patrons.
Ooh.
We've had a little bit of a surge recently, so we'll be there in no time. So if you want to make sure you don't miss out, head over to patreon.com/iknowdino. This week, in our 282nd episode, we have a bunch of news, including a new raptor from New Mexico and some new dinosaur decorations. And we have Dinosaur of the Day, Arcovenator. But before we get into all of that, we want to thank some of our patrons who have already joined and will be getting some art as long as their address is correct in Patreon when we reach 160 patrons. And this week, we'd like to thank Scotty, Megan Dixon, Kessler, Rhinosaurus, Morgan Eklov, Risa, Kelly, Manda, Laurasaurus, Timmy, James Pasco, Gabe, TRX Dinosaurs, and Michael.
Yay, thank you so much. We really appreciate you and our dinosaur enthusiast community, especially in these last few weeks. And if you want to join our community and come join us in watch parties, because we've been doing a lot of those lately, then check out our page at patreon.com/iknowdino.
This Saturday, we'll again be watching one of the Jurassic Park movies. We're all the way up to Jurassic World. We've watched the first 3 Jurassic Parks, and we'll be watching it at 1 p.m. Pacific Daylight Time, same time we did Jurassic Park 3 last week, but 6 hours earlier than the previous 2 that we watched, so that our European friends can join us. And if you want to get on that, then head over to Discord, because that is by far the best way to chat while watching the movie.
Yes, which is through our Patreon. And also, we'll be releasing some lesson plans, dinosaur-themed, of course, very soon for different age groups. They're already done. There's 16 of them. There's just one last technical hurdle I need to figure out, so stay tuned. That'll be coming soon.
Yeah, that's going to be for everybody in the world who wants it.
Yeah, so teachers, educators, if you want to keep your kids busy and learning science and critical thinking, then this place is for you.
And we're mentioning it now because it's really patrons that make this possible, because we had to buy some new web extensions and things to get it working on our website, and we couldn't afford to do all these cool things without the support of our patrons, so we really appreciate you.
Yeah, thank you.
Jumping into the news, our first new article is about a brand new dinosaur, a new raptor, also known as dromaeosaur.
Ooh, is this the warrior raptor?
It is. I'm surprised you already knew about it.
It was in all the headlines.
I don't see any dinosaur headlines anymore.
Good thing we work together.
That's true. So this article was published in Scientific Reports and written by Stephen Jasinski and others. And in it, like I said, they describe a new raptor. It's from the latest Cretaceous, also known as the Maastrichtian, which is, in this case, somewhere between 66 and 70 million years old. There are different, if you go by, I think, the radiometric dating, it's really close to the end of the dinosaurs. It was like 66.5 million years ago. But some other things about where it was found make it seem like maybe it's closer to 70 million years old, which wouldn't be quite as close to the extinction. But in terms of dinosaurs, either way, it's pretty late. So this dinosaur may have been alive. Not this individual, but this species may have been alive when dinosaurs went extinct. It's named Dineobellator, and it was found in San Juan Basin, New Mexico. That's a little bit to the east of the Navajo Nation, I think. From looking at the map, it's a little bit unclear where exactly the boundary is, but I think it's a little bit to the east of it. And that's partly because they didn't give the exact location, because sometimes they restrict that so that other people don't go in and pillage the site, I guess.
If there's any kind of poaching or vandalism, that kind of thing.
Yeah, exactly. Either way, it's not too far away from where so many of the Triassic Coelophysis individuals were found over the last several decades, which it was kind of surprising to me because I didn't realize that there was a Cretaceous formation so close to a Triassic one. They're like 150 million years apart. It's crazy.
So close and yet so far.
Yeah. We do have a couple of other late Cretaceous raptors known in North America. We've got Achiroraptor and Dakotaraptor, which are from the Hell Creek Formation, but that's way up in Montana and South Dakota, whereas Dineobellator, obviously, is in New Mexico, very far away. Sort of similar east-west-wise, but pretty far south. But it should have all been in Larramendi at the time. The full name of the new raptor is Dineobellator nodohesperus, and Dineobellator comes from Dine, which is the Navajo word for the Navajo people, and Bellator, which is the Latin word for warrior. So it kind of translates to Navajo warrior.
Oh, yeah. There's that warrior dinosaur.
Yeah. They left out the Navajo part in the title you read, I guess. And then the species name, Nodohesperus, comes from Nodo, which is Greek for southern, and Hesper, which is Greek for western. So we've got Greek, Latin, and Navajo going on.
Beautiful.
In the different names, yeah. And they called it Southwestern because it's from the American Southwest. And then they have a little footnote, basically, that's like, Hesperus also refers to the Greek god of the evening star, but that's not really the reason they named it that. They describe Dineobellator as a mid-sized raptor, which in their approximation is similar in size to Velociraptor, but that seems weird because Velociraptor I always think of as tiny, but I guess for a raptor, it's mid-sized. There are small, I mean, we got microraptors,
yep.
I guess, so if you're including that group, then it is mid-sized. But if you compare it like pound for pound, in the tens to maybe 100 pound versus something like Dakota Raptor, which is like 1,000, 2,000 pounds, then it seems really small. Also, based on the skeletal drawing that they have in the paper, it seems to be a little bit bigger than Velociraptor by the scale bar, which is in there, which I know Scott Hartman told us is like not the most accurate thing to go by, but if you use it because it's the best I could do, it's about 3 meters or 10 feet long and about 1 meter or 3 feet tall, which is maybe 50% bigger than Velociraptor as it's usually depicted. Obviously, a lot of that length is tail, so it could be longer with feathers if they were on there, or shorter if it didn't have as many tail vertebrae, because that can really impact things dramatically. And it probably weighed roughly, very roughly, like ballpark of 100 pounds, I would say. Because Velociraptor is usually like 20 to 50 estimates, and then this one's like 50% bigger, so roughly 100 pounds.
Mid-sized.
It would be terrifying in real life, that's for sure.
Mm-hmm.
The holotype has a smattering of about 20 puzzle pieces of bones. And it really is. It's like just random puzzle pieces. They're from all over the body. They go from almost the tip of the head to like one of the last vertebrae in the tail, and then all over the place in between. They don't have a single full limb. It's all just these little pieces all over the place. It's pretty crazy. So they have small pieces from the skull, which include a partial brain case. They have some of the sharp serrated teeth. They have part of its arm and a finger claw. They have both femora, or at least parts of them. They have pieces of the feet and a toe claw, although it's not the exciting curved toe claw. They also have a rib and then a few tail vertebrae, including the one that's the closest to the hips and then one that's nearly at the end. I have no idea how this thing went through taphonomy to get just those random bone bits preserved. It seems just too crazy.
A lot happened.
Something smashed it to bits and then scattered it, and somehow it ended up getting fossilized. But fortunately, the pieces that they've recovered are complete enough to be useful for comparing to some other raptors. And by doing so, they found out that the forelimb bones seem to show a higher grip strength than other raptors. So it might have had stronger claw digging ability on its hands. The base of its tail also looks more flexible, which they say could lead to higher agility. And to me, that makes me think of a cheetah. And when cheetahs run, they kind of swing their tail to the side in order to pivot more quickly. And the way they usually describe it is the cheetah tails are acting like a rudder. So they're running so fast that the air moving by them can be used as like a tool to sort of pivot their body by sticking their tail out, like sticking your arm out of a car window. It can force them to rotate.
It's interesting because usually we often talk about tails being rigid and then how that helps with balance.
Yeah, it can. So sometimes cheetahs will also stick up their tail vertically a little bit, and then it acts as a stabilizer because it's like a keel on a boat. Keeps all the air moving around it, and it's a little more laterally stable then.
All goes back to boats for you.
It does. especially with the Raptor tail fan, because they kind of look like oars. If you look at them, they tend to have less feathers sticking out at the base of the tail. Then they're often depicted as sort of flaring out with more feathers near the end of the tail, just like if you're using a paddle in a kayak or a canoe or something. And if you've ever been canoeing and you're in the back, you can do a rudder technique where you like stick the oar down in one side of the water and it'll turn the boat a lot more quickly. So that's basically the same thing that maybe this Raptor could have done if it had this oar-like tail with this feather fan at the end of it. It could stick it up in the air and then it could pivot a lot more quickly. So if it's chasing something and it changes direction suddenly, it can stick out this oar tail and swing around so that it can stay on top of it.
It's a very valuable tail.
Yeah. It'd be super cool. We don't really have any, I think the closest modern analog we have is a cheetah, because things that run like ostriches don't really have a tail, because no modern birds have tails. They have tail feathers, but it's just attached to that tiny little pygostyle, so they can't stick them out in the same way that you could if it was a real rigid tail.
I wonder what the advantage was to them losing their tail.
Probably flight. If you're flying, the tail is just getting in the way. You don't want a rudder. You just want to be as streamlined as possible. And it has extra weight too. Looking at Dineobellator phylogenetically, it sits within Velociraptorinae, and that's the group with the closest relatives to Velociraptor itself and a few other Asian raptors. So even though it was in Larramidia with these other Larramidia raptors, it's not as closely related to them as it is to the ones from Asia. And the researchers propose that that's probably because the raptors came over from Asia not too long before that, maybe around roughly 80 million years ago, in the Campanian-Maastrichtian sort of time frame, and then continued to diversify into different groups within the U.S. over time. So they didn't all branch from one single ancestor in the U.S. or Canada. The researchers summarize where they think Dineobellator fit in sort of the circle of life of the Mesozoic by saying that, quote, dromaeosaurids were active predators that occupied discrete ecological niches while living in the shadow of Tyrannosaurus rex until the end of the dinosaurs' reign, end quote. So I think in this analogy, T-Rex is basically like the lion, and then the raptors are more like the cheetahs, because the cheetahs are obviously a very specialized predator, still successful, but, they're definitely not the top dog or cat.
Well, yeah, they were more bird than anything.
It's true. And a lot of people do point out that cats aren't a great analogy for dinosaurs because cats are crazy and they often attack things that are way bigger than them, whereas birds and dinosaurs probably wouldn't really do that.
They're more realistic.
Yeah. And, they got those hollow bones. Maybe they're less durable. I don't know. Cats are just insane animals, whereas dinosaurs are relatively calm by comparison, I guess.
Well, we don't really know, right?
That's true. Just based on modern birds, at least. Unless they act like seagulls. Those things are crazy.
Oh, there's a lot of crazy birds.
It's true.
And birds that hold grudges. I wouldn't want to come across a non-avian dinosaur that was holding a grudge against me.
Telling all its friends to look out for you.
Mm-hmm. So in other news, there's a family near Stroud. This is in England. And the family includes James Booker, his wife, Emily, their 6-year-old son, Thomas, and their 3-year-old daughter, Olivia, who've created dinosaur art from rocks while on their daily walks at Selsley Quarry. And James said that the dinosaurs were a thank you to the NHS who helped Thomas, who has epilepsy, and also a way to bring cheer to people during lockdown for COVID-19. So apparently that quarry usually is, according to James, quote, filled with people's names or wedding proposals, so we thought we'd do something a bit different. And they started with Triceratops, and then Emily challenged James, like, okay, let's make a bigger one, a T-Rex. So they made T-Rex. It also looks like they've made a Brontosaurus or some sort of sauropod near a tree, and then Baryonyx or Spinosaurus. It's hard to tell for sure which one it's supposed to be, but it's got a bit of a sail on the back, and a pterosaur. And they all look really large. I have no idea how large they are, but much bigger than the people who made them.
I'm guessing these are like 2D sort of laid down rocks, like you're signaling an airplane in the sky sort of proportion.
Exactly. Flat. Very cool. Looks mosaic-y.
If they want to kick it up a notch, they got to start piling them vertically.
Oh, gosh.
Making it more of a sculpture.
I think I just want them to keep building what they're building.
Yeah.
Curious to see how far this will go.
By the time the shelter in place is done, all of the wedding proposals and names will be gone, and it'll be nothing but dinosaurs.
And last, we got some news about Jurassic World 3, Jurassic World Dominion, as it's now known. So Colin Trevorrow, who's directing the film, posted a behind-the-scenes photo of the set, and it shows Isabella Sermon, who plays Maisie Lockwood, in the snow. And that might mean that the movie will have dinosaurs in the snow.
That'd be fun.
That would be.
Maybe they'll bring in some Cryolophosaurus or something.
Ooh, yeah. That'd be fun. We'll see. But the production, they had to halt production back in February, so it's not 100% for sure that the movie will be released on schedule. However, Trevorrow said he's working on the film from home while production is shut down.
So production is shut down with an asterisk, except for the director who's still working on it.
Mm-hmm.
It'd be cool, too, if they had a Eutyrannus. They could finally have a feathered Tyrannosaur. Finish the last Jurassic World movie with some accurate theropods. That would be great.
Yeah, there's lots of room for possibility.
And before we get into our dinosaur of the day, another quick reminder that we have a Patreon. It's full of rewards. It allows you to watch movies with us via Discord or request dinosaurs of the day. We still have our Arc server up on there too. Some people are still playing it, so you can go create a little dinosaur, I don't know what to call it, zoo/battle group in the game by like taming dinosaurs. It's pretty fun. And of course, you can get ad-free episodes of the show and our books and things by joining at various levels. So definitely check that out if you're interested. And as we mentioned before, we also have Sabrina's art, which will be coming out once just 14 more patrons join. So if you want to make sure you don't miss out on the sweet art, then join within the next couple of weeks because we're screaming up to that next milestone. So no matter what you're interested in, we have some dinosaur content for you, and you can get it by heading over to patreon.com/iknowdino. That's patreon.com/iknowdino with no spaces, as usual for a URL.
And now on to our dinosaur of the day, Arcovenator.
Arcovenator?
Yeah, I guess depending who you talk to. And that's a request from Ad Astra via our Patreon and Discord. So thank you. Arcovenator, or Arcovenator, was an Abelisaurid theropod that lived in the Late Cretaceous in what is now France. And Abelisaurids had these short, tall skulls, very short arms, and stout legs. So that's kind of the gist of what this dinosaur looked like. It was medium size, originally estimated to be about 16 to 20 feet long. But then some scientists later, like Molina-Pérez and Larramendi, estimate it to be 23.6 feet or 7.2 meters long and then weigh 2,094 pounds or 950 kilograms. A nearly complete braincase has been found, and that braincase is similar in size to Majungasaurus and Carnotaurus. Arcovenator, or Arcovenator, had some bone ornamentation on the skull, but it wasn't as flashy as Majungasaurus. It did have a bony brow ridge, though, and the skull may have had a space for a pineal gland, which produces some hormones like melatonin. Arcovenator is a basal Abelisaurid, and it was carnivorous. It was probably an apex predator of its time. The type and only species is Arcovenator escadae, and the genus name means ark hunter, and that refers to the river Arc near where the fossils were found. The species name is in honor of the company Escada, which funded excavations since 2006. So the fossils were found in France when a construction company called Escada was working on extending the A8 motorway near the city Aix-en-Provence, and they found fossils in fluvial sandstones. And they found parts of the skull, caudal vertebra, parts of the lower right leg, as well as cranial material. And then referred specimens consist of 3 teeth and 2 caudal vertebrae, and that's not a whole lot of material, which is why I mentioned earlier what Abelisaurids in general looked like, so that you get an idea of what this one looked like. So Thierry Tortosa from the Museum of Natural History, Aix-en-Provence, and Eric Buffetot named and described the dinosaur in 2013. So the holotype's at the Museum of Natural History, Aix-en-Provence. Arcovenator shows that Abelisaurids, instead of Carcharodontosaurids, were the largest predators in Europe during the Campono-Maastrichtian, which is the latest part of the Cretaceous. Arcovenator lived on Ibero-Armorican Island, which is made of parts of what's now France, Spain, and Portugal, and it lived in a warm climate with seasons. and the fossils found in fluvial sandstone were probably the mouth of a river. Other animals in the same time and place included turtles, crocodilomorphs, pterosaurs, sharks, and other dinosaurs that lived in the same time and place included titanosaurs, the ornithopod, Raptodon, and nodosaurids. A phylogenetic analysis showed that Arcovenator is more closely related to Abelisaurs found in India and Madagascar than Southern American Abelisaurids. Genosaurus, Pteroscosaurus, and other late Cretaceous discoveries were identified as basal Abelisaurids. The discovery of Arcovenator helps show that, according to the paper, quote, Europe and Africa may have played a major role in Abelisaurid dispersal, which apparently involved crossing marine barriers, end quote. And that means that South America did not play as major of a role. So according to Tortosa and others, there's 3 main dispersal models to explain the distribution in the Cretaceous of Gondwanian non-marine vertebrates, and that includes Abelisaurids. And the first is the Pan-Gondwana model, where, quote, a common fauna was distributed on all the Gondwanan landmasses during the early Cretaceous before the severing of Africa from all the other southern continents during a relatively brief interval at the beginning of the late Cretaceous, end quote. And then the other model is the Africa First model, where, quote, Africa separated first from other Gondwanan landmasses, while terrestrial dispersal routes between South America, Antarctica, and Indo-Madagascar remained effective until a gradual breakup during the late Cretaceous, end quote. The problem with these first 2 models, though, is that it doesn't take into account animals from Europe, and Abelisaurids, such as Genosaurus, were in Europe, according to the authors, quote, before the total dislocation of Gondwana. End quote. So there's also a lot of similarities between Arcovenator and relatives and Abelisaurids in Africa, Madagascar, and India, and the origin of Abelisaurids was thought to be at the latest in the early Middle Jurassic in Pangaea. So the third model is the Euro-Gondwana model, and that includes something called Atlantogaea, where Africa and Europe and Gondwana had biotic interchanges, basically the fauna migrating, even after Gondwana broke up. So the discovery of Arcovenator helps show this Atlantogean idea and the interchanges between Europe and Madagascar and India. So Arcovenator is, according to the paper, quote, the first direct link between European forms, the primitive African taxa, and the derived Indo-Madagascan Abelisaurids, end quote.
There are a lot of similar papers talking about how South America and Africa were linked longer than other places, and it's really messy.
Oh, yeah.
It seems like the most likely thing is that periodically different land masses connected and disconnected, and so it wasn't as simple as this disconnected first and completely and never reconnected again, and then this disconnected completely, and so on. Is probably much more messy than that.
Right. And while that was happening, animals were always moving around.
Yep. And some of them could probably swim a little bit,
yeah,
which makes it even more difficult to see. And our fun fact of the day is based on a question I had with all this COVID-19 stuff just constantly bombarding us. And that's, what was the first dinosaur to get a virus? And by extension, do we know when the first virus evolved, period? Because at least if viruses were around in the Mesozoic, then you could know that potentially a dinosaur could have gotten a virus.
That seems like a hard topic to find the answer to.
It was incredibly difficult, and I spent about a day on it and still didn't get all the answers. But I'm going to summarize what I did find because I think there's a lot of interesting stuff. So dinosaurs were and still are susceptible to viruses.
Still are, meaning birds.
Yes, exactly. As a side note, though, it's unclear whether viruses are even living things. The computer analogy, I think, is pretty perfect. Viruses, just like their computer homonym, are random bits of code, basically DNA or RNA, that hijack systems to replicate. And that's basically their whole function. They don't do anything outside of these host organisms ever. So they're not like other parasites you might think of that sort of involve another animal in their life cycle. They only do anything when they're in another organism.
Weird.
So that's why some people don't define it as a living thing, because it literally only does anything by interacting with another cell. But then some people say, well, it's doing something. It's affecting that other living thing, so that makes it a living thing. And it can even get into your genetic code, too. So at the very least, it's a handy way to do horizontal gene transfer. And what that is it's like, Basically, when a virus jumps across species, it can take a piece of genetic code from one species and insert it into the other species. And that can be really useful over geological time in terms of evolution, because you can end up with new code that you wouldn't have been able to get otherwise. But obviously, viruses also do a lot of bad things. Most notable for current dinosaur viruses is influenza, or as common parlance would put it, bird flu.
Bad birds.
Yeah. Usually when people say bird flu, they're talking about H5N1 bird flu, which is a very specific strain. But according to the CDC, aquatic birds all over the world frequently catch different strains of bird flu, and that includes gulls and waterfowl, which again is ducks, geese, and swans among their relatives. But it doesn't usually affect them that much. So just like the flu in humans, in a typical year, the flu symptoms are not severe in most people, and you get a fever, and then after a few weeks, you're kind of back to normal. Although obviously some years are a lot worse, and there can be a lot of deaths. But in general, it's not a huge pandemic crisis. Same kind of thing in birds. They have their own flu seasons. They're all giving it to each other when they migrate. They run into each other, or sometimes they migrate and they run into poultry, or they run into people's pet birds. And then they can actually spread their aquatic bird flu into poultry. And then obviously they have a lot more contact with people in that situation. As a side note, there isn't a ton of research into where flu came from. It's like a really hard thing to find. Usually, it seems like almost all the research is focused on when did people first get the flu, and nobody cares about when birds first got the flu. If you search for that, you just find when did birds first give the flu to people. But from what I can tell, it seems that the consensus is the flu probably evolved in dinosaurs or birds, and then eventually some of the strains were passed on to pigs and then people.
So we should blame the dinosaurs.
Maybe. Or you could blame the pigs or some other mammal, because it turns out it's really hard to catch a flu strain directly from a bird. It usually goes through a mammal intermediary that is susceptible to bird flu, and then also is close enough in virology passing on ability to us that, we can end up catching it from them. And as an example of that, there was a bird flu strain in 2015 in the United States in which we ended up killing 43 million birds, either because they had the disease or because they were near other birds that had it and we were trying to prevent the spread. And that was an H5N2 strain, and not a single human case was reported among tens of millions of birds across multiple U.S. states.
And those were birds in the Midwest.
Yes. So as a result, we're not really worried about H5N2, but H5N1, which is the one that people call the bird flu for shorthand most of the time, because that's a very deadly one, at least in humans. We have done a lot of preparation for it. In fact, the U.S. government has a stockpile of vaccines for H5N1 in case there is an outbreak in people, so that we can hopefully prevent the spread of it. But like I said, I can't find any sources on when influenza evolved, just period, and even what animal it evolved in. I think it's birds based on the things I've seen. I'm wondering if maybe it's just super hard to figure out from the paleontological record, because viruses cause very similar ailments to other microorganism infections. And sometimes there's just no trace of it once the animal dies. So like if you died from a fever, you're not going to have skeletal effects. At least we don't know how to see them now. Maybe in the future somehow we'll be able to tell. But a lot of the ways that viruses affect animals just don't fossilize. And viruses themselves don't fossilize because they decay really rapidly, because they're basically just fragments of DNA. So any time scale where the DNA would break down, the virus is gone too.
Just shows you how weird evolution is.
It's super weird.
What's their purpose?
They're good at causing more mutations, which is helpful. Like we probably wouldn't be here without viruses. So I guess that's a positive. So on to what we do know about Mesozoic dinosaurs. Is obviously much less, but there's a whole field called Paleo Virology, and it mostly focuses on dating viruses by estimates of mutation rates. Because like I said, they don't fossilize, and most of the evidence of viruses don't even fossilize. So what you do is you find two related viruses, and then you see how much genetic material they share in common. And then you can estimate how many mutations would be required in order to get to that sort of distance. So it's sort of like if you're testing people's DNA and then you're not sure if you're related to somebody, and you look at both of your sets of chromosomes and you see like you have, say, 10% in common, you could figure out how far back in the family tree you have to go in order to have a common ancestor. So you could say, oh, we're third cousins, it turns out. Same kind of thing with these viruses, except that you're estimating a common ancestor on the millions of years timescale rather than just generations. So based on this methodology, we've seen different virus branches which have emerged between 100 and 300 million years ago. So different sorts of virus families. There's a whole crazy family tree of viruses all over the place doing different stuff. One of the ones that a lot of people research focuses on infecting wasps and changing their behavior. That one I think was 190 million years ago. None of them that I saw were specifically about dinosaurs, unfortunately. So I don't think they've really gotten into that.
Were there some on mammals?
Yeah, there's a lot of research on mammals because that's more important to us, I suppose. But given the fact that we know viruses were around before the first dinosaur evolved, it's probable that most dinosaurs dealt with viruses because it's just so easy to get infected by viruses and so easy for them to spread. And we have covered dinosaur injuries in the past, which may have been caused by viral infections. It's just really hard to distinguish a viral infection from like a bacterial infection or a fungus or any of these other types of things that can cause, say, bone loss or strange bone growths or things like that. So we're not totally sure, but it's probable. And then another piece of evidence is that there's a cockroach, or cockroach, as I like to say it, from Late Cretaceous amber in Myanmar, which again is controversial. And it appears to have had deformed wing virus, which still exists today, most notably in honeybees. So it's this weird virus that if they get it when they're developing, it basically means that they don't grow wings.
Oh, then they probably get kicked out. They're useless.
They just die of other problems because that's not the only thing that it comes with. It causes other problems in the bees. So they only live for like a day. But the wings on this cockroach look really similar. So it's really likely that it had the same thing. But that's sort of what I was talking about with how things don't fossilize that are the results of viruses, because usually bug wings don't fossilize. So you'd have no way of knowing this unless you find it in amber and you get some soft tissue preserved, and then you can see it.
And then you have to know that it looks different from other bug wings.
Yeah, exactly. The right person has to see it and recognize it as similar to this abnormality that happens in certain honeybees. But the fact that 100 million years ago, this bug had the thing that looks almost exactly the same as it does today, you have no idea when it could have started. It could have started 300 million years ago. It could have started with the very first flying bug. Shortly afterwards, this virus popped out of it as a random mutation. So it's so hard to tell. But viruses, like I mentioned before, aren't all bad. There's a new article that postulates that maybe mammals survived the KPG boundary better than dinosaurs because of some viral genetic material that we had inserted in our genomes due to a previous infection. Because part of the way viruses work is they insert their own genetic code into the host, and afterwards the host is just replicating that DNA, which is basically the virus. But sometimes if the animal survives and passes on offspring, they'll have a little bit of that virus code in their DNA, and it can make it harder for viruses that are related to it in the future to attack that organism. And the bit of virus that seems to have been in these late Mesozoic mammals is closely related to some pretty nasty stuff like Ebola. And if during the KPG boundary, the animals were already stressed and dealing with, the nuclear winter basically that was happening, and there was also a virus that was spreading around, the mammals may have been better prepared to handle it because it didn't affect them as much as maybe it did birds. Super speculative, though, which is why I didn't use it as a news article, because it just seems a little too far out there.
It's more of a thought experiment at this point.
Yeah. It's interesting, though. It kind of helps to show some of the animals and how they're related, because you can see the same virus fragment in a bunch of different animals. And then what they did was they went back in time, and they know the common ancestor was in the Mesozoic, so they know that the ancestor had to have been infected way back in the Mesozoic. I realize that's kind of circular logic, though, because I'm saying the viruses are good because they protect you from future viruses. The horizontal gene transfer thing is probably a more overall positive thing, that you can actually get new genetic code you wouldn't get otherwise. And just so we don't end on a huge downer, we've got an interview with Phil Tippett coming up next week.
Nothing to do with viruses.
No. Everything to do with Jurassic Park and Star Wars, because he did the special effects for the Star Wars movies, at least the first 3 of them that everybody loves. And he was super important in getting the CGI in Jurassic Park, the original Jurassic Park, to look right. So if you're at all interested in Jurassic Park or special effects, next week's interview is going to be great.
And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. And join our Patreon if you want to join in on our watch parties, our dinosaur watch parties. Jurassic World is next.
And get Sabrina's art.
Yes, that too. That's patreon.com/iknowdino. Thanks again, and until next time.